Hi everyone, today we're going to talk about deep sea mining. This is an issue that I never expected that I would be teaching about in a class. For one, because I've always thought that the whole concept of mining in the deep ocean was science fiction, and I never thought this would be something that we would actually be doing, and I certainly never thought it would be something that I would be teaching about, and I'll explain why I am. So the whole topic really came to my attention in a somewhat surprising way. I've talked to you guys before about the Lost City hydrothermal field, and what I didn't mention before is that the Lost City is such an unusual natural wonder that the UN has actually recognized it as a potential World Heritage Site. UNESCO put out a report proposing that we should find a regulatory way to recognize marine natural wonders that are not in any national borders as UNESCO World Heritage Sites. This is actually not possible right now because the way the law works, you can only have a UNESCO World Heritage Site in an area of the Earth that is governed by a national government. And the open ocean is not governed by any one government. And so there's a bit of a legalistic thing about whether the UN has the right to call these UNESCO World Heritage Sites. But the Lost City is one of the first marine features that has been proposed to be recognized as such. And the reasons are things like it's a superlative natural phenomena or natural beauty. It represents major stages in Earth history. That's referencing the potential implications for the origin of life, significant ecological and biological processes and evolution of ecosystems. We talked about that. And significant biological diversity and threatened species of outstanding universal value. And we never really thought of the organisms at Lost City as being threatened until a few years ago, a colleague forwarded me an email that was announcing that the region of the seafloor that includes Lost City, so here is a map of the Mid-Atlantic Ridge. The Mid-Atlantic Ridge, again, is this underwater mountain chain in the middle of the Atlantic Ocean. This is where the Lost City is. And this chunk of seafloor had been awarded to the government of Poland as a mining exploration contract. And when I first heard this, I thought there must be some mistake. I couldn't believe that any regulatory agency would give a single government the right to explore places like this for mining. That just seems kind of crazy. And also, I didn't think that anyone would really think that mining the seafloor could be profitable, because I know how difficult it is to work on the seafloor. Everything always goes wrong when you're working on the seafloor. I just seemed like science fiction. It turns out the agency that is responsible for awarding mining contracts in the open ocean, where no single government has exclusive rights, is called the International Seabed Authority, which is a body within the UN. So this is a case of two different organizations, both governed by the UN, International Seabed Authority and UNESCO, were not talking to each other, apparently. And when the International Seabed Authority was asked about this, they acknowledged that they knew that places like Lost City were contained in these areas that had been awarded for mining, and that was it. They just acknowledged that they were aware of that. So next I'm going to play for you this video that actually does a pretty good job of introducing the topic of deep sea mining and mentions the involvement of Lost City. It features a colleague of mine, Gretchen Fruh-Green, who was involved in the initial discovery of the Lost City back in 2000. So here's that video.
Somewhere deep beneath the waves of the Atlantic is this. Spectacular, shimmering pinnacles and rocks which have been named the Lost City. There is no other place known on Earth that is anything like it. Here, despite the absence of light or oxygen, hydrocarbons, the very building blocks of life, are being spontaneously created in a reaction between these rocks and the seawater. Scientists believe life on Earth may have begun in a place like this billions of years ago.
We know from the rock record that these type of rocks existed during the early Earth. We know in different parts of Earth's history that we have these type of rocks, but we've never found it on the seafloor. Being able to understand the processes and the whole system of Lost City, being able to understand it now could give us clues as to what went on in the past and how life started.
Yet today, it is under threat. Sky News has learned that the Lost City has now been designated as part of a mining exploration site given over to Poland. The decision was taken by an institution called the International Seabed Authority, a UN agency based in Jamaica.
The Lost City is an active hydrothermal vent, and it is in the area that has been allocated to Poland.
The ISA's job is to decide which parts of the seafloor in international waters can be mined by which country. But some have asked whether it's paying enough attention to the environmental consequences.
I think the ISA has a pretty good record of transparency. The meetings of its political bodies are all public meetings held here in Jamaica.
We know very little about what happens inside those meetings and how those decisions are taken.
Recommendations are made by a body called the Legal and Technical Commission, which is a body that is elected by the countries and is empowered to review the applications.
How many people are on the
At the moment there are 30.
Have you ever, in the ISA's history, rejected a licence application?
No, so far no licence application has been rejected.
And for environmentalists, there are no easy answers.
So why do we need to go down towards the seabed? Well, it largely comes down to these. The primary ingredient in mobile phone batteries and batteries in electric cars is cobalt, and 90% of the world's known resources of cobalt lies in structures underneath the sea. Same thing for the big ingredient when it comes to solar panels. In other words, if we want to have a green future, we might have to go and mine the seabed.
And this British company is making the machines that will enable us to do that.
Why do we need to go under the water to mine?
Well, we've got a growing population around the world. Coupled with that, that population, per capita, their mineral requirements are increasing as countries develop. If we look at our sources on land, most of the easy, better deposits have been mined.
For decades, deep-sea mining was a pipe dream. Now, that dream is looking increasingly like a reality. With major consequences, we are only now starting to calculate. Ed Conway, Sky News.
So as you heard in that video, the reason why we are talking about deep-sea mining right now is because batteries, our electronic devices, and especially our batteries, are very metal hungry. The batteries in our cars, in our electronic devices, our smartphones, our whole battery-oriented culture right now is in need of a lot of metals. And mining metals on land has a bunch of environmental and humanitarian issues. Almost all of the world's cobalt right now is mined in the Democratic Republic of the Congo. And there are a bunch of political and humanitarian and environmental issues related to that mining activity. And it has led to calls for the major tech companies like Apple and Tesla to reduce the amount of cobalt in their batteries. And so that is something that's ongoing. Tesla has announced they're trying to reduce the amount of cobalt in their batteries, but it's a problem. And the people who advocate for deep sea mining say that mining metals from the seafloor is more environmentally friendly and has many fewer humanitarian issues than mining on land. And that is actually a good point. There are, in fact, lots of metals to be mined from the seafloor. This figure is summarizing the 4 major categories of habitats on the seafloor where you can mine metals. So previously we've talked about hydrothermal chimneys. So hydrothermal chimneys are, in fact, big deposits of metals. And there are efforts and plans underway to actually crush and collect hydrothermal chimneys and pipe them up to the surface so that we can use those metals. In previous lectures, I've talked about how active chimneys and inactive chimneys, here they're called sulfides. It's another word for chimneys because hydrothermal chimneys are almost always composed of metal sulfides. So active chimneys and inactive chimneys, we've talked about in previous lectures, are different kinds of microbial habitats. When the chimneys stop venting water, they are still an important microbial habitat, and they are also, according to some people, important resources that we should think about mining. Cobalt crusts are places of the seafloor that are rich in metals, especially cobalt, that are exposed. So these are places like seamounts. Seamount is a word for an underwater mountain that are emerging and are not covered by very much sediment. So you can easily access that bedrock that is rich in metal. This figure is showing that the problem with that is that these seamounts are actually really important marine ecosystems, and they have elevated biological diversity, elevated biological activity in these same places that are good for mining cobalt. This comes from a paper that I was involved in writing with a bunch of microbiology colleagues. And so we also highlight that these are microbial habitats as well as habitats for animals. So that's why we have these micrograph images up here as well. And then the fourth kind of metal that you can mine on the seafloor are these ferromanganese nodules, sometimes just called manganese nodules or iron manganese nodules. And that is being shown in these little red dots here. And these are little clusters of metal that form on the seafloor, probably at least partially a biological process, and they collect in places where ocean currents kind of concentrate and bring things together. And it's actually, the process of forming these nodules is fascinating and is an active area of research. We don't actually know how these nodules are formed exactly. There must be some biological component. But anyway, they collect in places, and because of the very high content of metal, these are also being considered for mining on the seafloor. So where on Earth do you find these places? Well, pretty much everywhere. We've talked before how hydrothermal chimneys are located on these mid-Atlantic ridges. So wherever you have ocean spreading centers, you are likely to have hydrothermal chimneys. And those are places that mining companies are thinking about mining. You generally don't want to go near 400 degrees Celsius water, and so usually they're really thinking about mining inactive chimneys, where you basically find those in the same places where you find active chimneys. These purple areas are the iron manganese nodules, and again, these are kind of found in places in the seafloor where sediments accumulate. And then the orange regions are cobalt crusts. So again, these are the seamounts that are poking up and are rich in metal. You find those in these orange regions. So these green areas that are especially clustered in the mid-Pacific here are places of the seafloor where mining exploration contracts have been issued by the International Seabed Authority, the arm of the UN that awards mining contracts. And you can see there's a lot of activity right here in the mid-Pacific. A couple of reasons for that. One is that there's this big outcrop of cobalt crusts that you might be able to see in the purple underneath all that green. And it's near Japan, China, and the US, which are the big actors in deep sea mining right now. All right, so how would this actually work? Here's a figure showing the general idea, which is that you put a giant machine on the seafloor that just kind of plows the seafloor up, collects the minerals that are kicked up from your plowing activity. There's a little bit of mechanical processing and by the machine itself, but basically it just chops up the seafloor and puts it in a tube and pumps it up to a support vessel on the surface. There's some kind of processing that occurs in the support vessel, which I'll talk about on the next slide. Here, this is showing that this works basically the same way for the cobalt-rich crusts, the hydrothermal chimneys, and the manganese nodules. Work slightly differently depending on which of those you're actively mining for. And then here is showing the many different kinds of environmental impacts this is likely to have. So the most immediate one is that this giant machine plowing up the seafloor is going to obviously kill anything that is living in the seafloor at that particular spot. you are not only killing those organisms, but you're destroying that habitat and probably won't be habitable again for some time. There has so far been one major study that I'm aware of that did a simulation of the effect of this mining activity on the seafloor, where they just plowed up a chunk of the seafloor and compared it to a chunk that had not been plowed up. And their estimates were that the part of the seafloor that had been mined might not be habitable again in the same way for decades or even hundreds of years, because the seafloor is a place where things happen slowly. It's not going to recover quickly in most places. All right, so you've got organism death, you've got habitat loss. There's a sedimentation that occurs from this plowing activity. So you bury the organisms that do survive. So the organisms directly in the path are dead, and even the organisms that are not directly in the path but are living some distance away, and that distance is to be determined. There haven't really been any good studies about how far away you have to be to escape, because the sedimentation plume from this plowing activity can go quite far, and so you can be buried underneath this even if you weren't directly in the path of the machine. The sedimentation activity is probably going to be associated with some kind of chemistry that has not been studied in the deep sea, but could be similar to what happens with acid mine drainage on land. So that's something that still needs to be studied, but there could be even further downstream effects from this aqueous chemistry that is kicked off by this injection of metals into the ocean. These particle plumes is related to the sedimentation. And then after the processing that happens on the ship, they're not just going to ship all of their waste back to shore with them. They're going to pump a lot of their waste products back out into the ocean and release it at some depth, and then that will have unknown effects as well, and perhaps a much more widely distributed effect. The idea is that if you distribute it at a shallow enough depth, that the effects will be diffuse enough that nobody will notice. But again, that is to be studied. We really don't know how this is going to work, and that is a good opportunity to say that this is not actually happening yet. This is all basically in the future. It is a bit alarming to the detail in which these plans have been made. So there are mining interests who have really put a lot of thought into this. There are plans for this. There are prototypes that have been built. But this is not actually happening on the seafloor anywhere yet. This, however, is already happening, which is exploration. So this is basically how we scientists explore the seafloor, and that is, of course, going on. But the amount of funds that are now being funneled into commercial interests exploring the seafloor for the purposes of mapping out regions for mining is increasing rapidly. All right, so now I want you to watch this video of a BBC News report on the first ever commercial deep sea mining activity in Papua New Guinea. So I just said that this was not happening yet, and that's because the video you're about to watch is of the first ever commercial mining effort, and it went bankrupt and failed. So that is why I said it's not actually happening yet. But it's interesting to see what they tried to do in Papua New Guinea in the past couple of years. So watch this video.
Of Papua New Guinea, preparations are underway for the world's first deep ocean mine. Rocks found on the ocean floor are exceptionally rich in copper and gold, could be worth billions of pounds. But scientists are warning that the mining of the rock will devastate marine life, and Sir David Attenborough is among those who's condemned the plans. Our science editor David Schuckman has been given exclusive access to the project.
In the brilliant tropical waters of Papua New Guinea, a controversial project is taking shape that could have a huge impact on the oceans. A vast, lumbering machine is going through final testing. It looks like a cross between something military and an invention from science fiction. Its whirling steel teeth are designed to break up the rocks of the seabed. This will be part of the world's first deep-sea mine. This is the first time that anything like this has ever been tried, sending these massive machines a mile down to the ocean floor, and there, well, tearing it up to send valuable metals up to the surface. And because this is all so new, no one really knows exactly what the impact is going to be. The company behind the mine portrays it as a neat and efficient way to get at rich deposits of gold and copper. And it claims there'll be less disruption than there is in mines on land.
The offshore alternative is, in fact, from an environmental perspective, a far better way to provide the world with the minerals that it requires. Offshore, there will be no clearing of rainforests, there will be no relocation of communities, there will be no large waste dumps.
But not everyone believes all that. Fishing supports thousands of jobs in Papua New Guinea, and some here worry that important tuna stocks will be at risk. The UN Development Programme wants the mining project stopped.
1/6 of the tuna in the whole world comes from the Pacific and from this one country. Huge numbers of people's lives depend on fisheries, and this project potentially will jeopardize all of that.
So there's a difficult balance for Papua New Guinea. Millions here live below the poverty line. This is one of the poorest countries on earth. But mining projects on land have often failed to improve conditions. As a developing country, Papua New Guinea is obviously looking for new sources of income, and deep-sea mining may help provide that. And if it works, and it is a gamble, there are dozens of other mining projects around the world that are likely to follow. So what happens here could really usher in a whole new era of what we do to the oceans. The first project will target deep, hot springs known as hydrothermal vents. They're packed with minerals needed for electronics and renewable energy, so some scientists say we'll have to mine them. But others warn that teeming communities of rare forms of life could be wiped out.
It's heartbreaking.
We showed David Attenborough our video of the ocean mining machines. He's horrified at the idea of the destruction of hydrothermal vents.
That's where life began. And that we should be destroying these things is so deeply tragic. I mean, that humanity should just plough on, just with no regard for the consequences, because they don't know what they are.
Brake control has been disabled.
Back in Papua New Guinea, testing continues. One major concern among critics is that the government here is a shareholder in the mine,
Okay, sweep in.
raising doubts about its ability to step in if things go wrong. But staff here say they'll try to minimise the impact.
We're not in an environment that we can just do whatever we want. People are watching, there are regulations that we need to abide by and modify to suit so that the environment is the winner in the end.
One of the giant machines is tested underwater. In the next 2 years, it'll be lowered to the seabed and put to work. The start of a new gold rush in the deep ocean. David Schuckman, BBC News, in Papua New Guinea.
All right, so as I said before the video, that effort failed. Investors pulled out of the whole thing, and it's I don't know if the investors pulled out more because of the environmental concerns or the humanitarian concerns, or just because they thought the thing wasn't going to make any money. I would guess the latter, because it's hard for me to imagine how any of this could be profitable. It required so much investment up front, and the chances of something going very, very badly on the seafloor are very high. But anyway, it didn't work out. As far as I know, it is not starting up again anytime soon, but all that equipment still exists. I'm sure someone's going to try again. And I think in the meantime, an interesting aspect of all this is that the government of Papua New Guinea, which is it's a developing nation, as you saw in that video, they were doing this because they need the money. And in the end, they lost $150 million. So I think that I'm focusing on the biological and ecological aspects of this whole thing, but there are political and economic aspects to the story as well. So my involvement in this, once I heard that the Lost City was included in a mining exploration contract, was to get involved in the best way that I can. So here is a summary of some of the responses by scientists and environmentalists when we got this wake-up call that this was actually underway. So here is a really good report from the International Union for Conservation of Nature. They're highlighting Lost City on their cover, and they do a good job of summarizing the environmental and ecological concerns about deep sea mining. Here's an article in Nature summarizing the topic and how it's becoming more and more important. And here is a podcast that came out last year on the topic. They had multiple episodes, and I was included briefly to talk about the Lost City and why the Lost City is so interesting. So if you want to hear me talk about the Lost City again, you can check out that podcast. So we microbiologists also wrote a paper talking about the specific impacts to microbial ecosystems. And this is the title page of our paper. And we were inspired by this recent paper on marine ecosystem services as an important component of managing deep sea bed mining. So here is a generalized framework for ecosystem services. So the idea is, the whole idea with ecosystem services is that you can put a dollar value that ecosystems provide to society. And if you can value ecosystems in terms of dollars, then you can include that in your managing system and deciding whether to try to exploit that natural resource or how to exploit it and what is the cost-benefit ratio. And so you can see here there are these multiple tiers of considering the services that an ecosystem provides. It can include things like thinking about the services to the ecosystem itself. So these are the biological things that you would care about as a biologist. But even if you are not a biologist, there are these three categories of services to humans. So these can be things like fisheries. A lot of these places that are thinking about being mined are going to impact fisheries. These are places where we can discover new drugs and other useful materials. If we destroy them, then they're no longer useful in those ways. These habitats can be important for the overall global climate regulation. Other things that we don't normally think about the ocean doing for us, like managing our wastes for us. Cultural services as well. The ocean is an important aspect of living on Earth. And there are educational, aesthetic reasons why we care about nature. And the field of ecosystem services tries to place values on those things. And so in this paper, we using this framework from these folks, we talked about how microbial ecosystems in particular are contributing to these things as well. And the potential impacts that mining could have on the microbes in particular. So that's my lecture on deep sea mining. Just as a parting thought, my main concern here and the reason why I've gotten involved is because I have the privilege of having an intimate appreciation for how little we know about the seafloor, and the thought that we would start carving up the seafloor and exploiting it in ways that we don't really understand before we've ever really even explored these places really makes me concerned. And I was just talking about ecosystem services, and it's really hard for me to imagine how we can put a price tag on places that we haven't even explored yet. And that for me is the specific thing that I would like to see with deep sea mining regulation in the future. Is I think that there are good arguments why the ocean could be a better place to get these metals than land, but at the moment there is zero regulation about how that could happen. And that is how we get to the place where places like Lost City are included in mining exploration contracts, because there's no communication with scientists, there's no communication with any of the other stakeholders besides the commercial mining interests, and that has to change. We have to do this in a smart way. We need to do it in a way where we don't destroy things before we ever knew that they were there to begin with, and we are not doing that yet. I last year joined a letter of concerned scientists to the UN expressing our concerns that this was not going, that we were not going about deep sea mining in a very intelligent way, and we are still waiting on a response. Essentially, we haven't received any acknowledgement that the letter was received, and so that's where our efforts are focused at the moment. Is just trying to get a better process for making these decisions at the UN. I will keep you updated on Canvas. I posted a bunch of additional videos and readings if you want to know more, and that's it. Thanks for listening. See you later.